Welcome again to my channel, guys. Today we'll be talking about Newton's third law, which is very much interesting, and uh, there are some misconceptions about Newton's third law that I'm going to clear in this video. So let's start. So here, as you can see, I have a blank wall here, and here is a tennis ball. So now I'm going to throw this tennis ball on the wall. Oh, it hit the camera. So as you can see, when I just roll it, it's coming back. The question is why? Or another simple thing, that when I leave it from air, it bounces on the floor. It bounces. The question is why? So now let's answer this question. So let's talk about the wall example. It is because of the Newton's third law. So Newton's third law tells that when an object, I'm going to explain it in the simplest way. Listen very carefully. When an object applies a force on a surface or any other object, the surface or the object will apply the same amount of force on the object which applied force. Suppose here is this. So in this example, here is the ball. This is one object. The second object is that wall. That is the surface. Now, when I'm rolling this rolling this ball towards it, it hits that wall. What it means, it applies some force on the wall. Boom. And then when this ball applies a force on that wall, the wall applies a same force on the ball, and so the ball moves backwards. This is the explanation. Now I will find some questions from this. That is, I think you may be able to answer it, but these questions that I'm going to ask you now will help you to work on your mind. You will be able to understand it. So let's start with some questions that is going to help you. It's going to warm up your mind. So let's start. So now let's look at some examples of Newton's third law that we saw about the ball. The same way, but I'm going to ask you some questions. In this case, some misconceptions will be there. So let's understand. Now, the same example we'll draw here. This is 1 minute. So suppose this is the wall, this is the surface. This was the wall, okay? And now there is a man. For simplicity, I am drawing a man who is applying some force on this wall with his hands. So he's pulling he's pushing this wall, basically. Okay? Or we'll not take a man, we'll take the ball only, because that will make it simple. So let's take the same thing. Here is the wall, and here a ball rolls on the wall and hits the wall. Now it applies a force on the wall. That's okay? It applies a force on the wall. So when it applies a force on the wall, so here is the ball and here is the wall, and now when it touches the wall, it is going to apply some force on the wall, but this wall does not move forward. But that is one question. Okay, leave it. So suppose the ball touches this and it applies a force, but the wall does not move. The wall applies a backward force, an opposite direction force, and it moves the ball. But now the question is, so one thing is this, that this force that was applied by the ball on the wall would be same as this force. It would be same as the wall applying a force on the ball. Both will be same. Both are equal. Okay. Both the forces are equal in magnitude, but the directions are different. So this is in this direction, this is in this direction. But when it is putting the same force on this wall, the wall does not move. Why? This is a very simple answer. It is not actually some different thing. It's a very simple answer. This answer, that it applies the same force, both forces are same, but still the wall does not move, the ball moves backwards if you apply a force, the same force. The question is why? So this would be answered in a very simple way. The answer lies in Newton's second law. We all know that if the mass of something is more, then more will be the inertia, and so there will be less acceleration. So this is at rest, the wall is at rest. So the wall is having a, I know that wall is having a more mass, relatively more mass than this ball. So it would not move because of inertia. It would not change what it's doing. It would not start to move because it is having more mass. So I hope you got this simple answer. Now this thing that I showed you, this relates with something else that I'm going to show you now. So this was basically a simple thing about Newton's third law that I explained now. Now let's look at another example, the similar thing, but use it in a different way, in a different example. But I hope that you are clear with Newton's third law. It's really simple. Now let's get to the next example. In the next example, we'll see about gravitational force. Okay, so here we suppose our planet, and here is a small apple. Okay, it's not visible in the camera. 1 minute, guys. Small apple in the space, in the sky. Now the apple falls down. The question is why? It's because of the gravitational force that is pulling this apple down towards the center of the earth, or on the surface, or we can tell the center of the earth, because that's the main point where it is originating, and then when it lands it has the normal force acting. That is different thing, but here as we are seeing it, so it will apply some force on the apple and the apple will move down. But as we know in Newton's third law, as the earth applies a force, a gravitational force that attracts the apple down, the apple is going to also apply the same amount of force on the opposite direction on earth. So it is going to pull the earth up. So here here as we are seeing, there is some kind of Newton's third law acting. So the earth is pulling the apple will also pull the earth with the same force but in the opposite direction that I've shown in the arrow. Now the question is that if it is pulling at the same magnitude but different direction, okay, then why the earth is not moving towards the apple? Why the apple is moving towards the earth? A very similar answer. It lies in Newton's second law, that earth is having a relatively more mass than a small tiny bit apple. It is no consideration. It is very much different. The masses of both the objects are very much different. So when the apple pulls the earth with the same force because of Newton's third law, the earth, as it is having a large mass, it would not go towards the apple, because this earth does not want to move. It does not want to accelerate. Because it is having a mass and thus having more inertia, it does not want to accelerate. But the apple, as it having a less mass, as in Newton's third law, there is forces, and this apple is having less mass, so it doesn't having less inertia, and so it wants to accelerate. It wants to come down towards the center, towards the earth, and so the apple moves towards the earth, not the earth move towards the apple. It's impossible, as we know that. It's very simple. So basically this was a very simple video. It's not much detailed. It's detailed. The Newton's third law, I've explained it in a detailed way. This is the most basic part of Newton's third law that I've explained, and these are the two examples. there might be some questions, and questions that why it happens if it's having the same force, then why it does not move. I know that if you have this question, then after researching, you'll find the answer eventually. But I hope you enjoyed this video. I hope you got the answer to that question. I hope you all know that, but simply just a video about Newton's third law that is going to clear your doubts and clear the concept about Newton's third law. So I hope you like this video. Stay tuned for new videos, and goodbye. Have a nice day.